Hey, you ready? We're gonna go quick on this one. Okay, bye.
Okay, he's right though.
We got to go quick at the first on this one because we're going to hit up some modeling and covalent compounds, and we got like 9 examples to show you.
Yeah, we want to get through them all so you understand how to draw them. Let's get the rules down first.
These are the official IUPAC type named rules for drawing pictures of molecules. Okay, first,
Count up all the electrons.
valence electrons.
Right.
Second, connect all the atoms together with a single bond. So like connect them all first.
And that's
That
that dash.
central atom is the one that makes the most bonds or is missing the most valence electrons.
Carbon always wins.
Carbon will always be a central atom. So will nitrogen, etc.
Right.
Count the total electrons used after you connect.
Right. Each dash now is 2 electrons.
Very important. I'm going to underline that because that's a fact beyond the rules here.
Yeah, that's actually sometimes a multiple choice question.
Testable.
Yes.
Question.
How many electrons are present? Yep. And then I'm going to add electrons in pairs around the outside atoms until I get to whatever that number is that I counted to.
Mm-hmm.
Now there's 2 scenarios. Either I haven't used them all.
Right.
That's when I throw some extra pairs on the central atom.
Right. Like if you had 12 electrons to use, but you only used 10 by connecting all the atoms.
Right. Then boom, put in 2 more after I did all my lone dots.
Or you run out.
Ooh, and if I run out, this is where it gets fun.
Right.
We get to make different things. We're going to take lone pairs and move them off of the outside atoms into making multiple bonds in the central atoms. We'll show you how to do that when you're all done. Redraw.
Now, there's a set of rules, and then there's a visual set that I'm going to also show to you once we get into the thick of it. So, Mr. Milks, first thing, H2, the simplest molecule in the universe.
Yep. So each H brings 1. So how many
One
total
valence
electrons?
So we got 2 total electrons to play with.
All right.
And he is going to connect them first and then count and see. That single solid line represents 2 electrons. So he's used the 2 electrons that he was supposed to. Hydrogen has 1 valence electron. So there we go. We check for duets in the case of hydrogen. Each hydrogen atom is in contact with that solid line. So each hydrogen atom has 2 electrons around it. It's happy. The next example, HCl. This is your stomach acid in a molecular form. He's counting the valence electrons, 1 from hydrogen and 7 from chlorine. So he has 8 total. He's going to connect the 2 atoms with a solid line representing 2 electrons. And then he's going to put he's got extra. He's only used 2 electrons to connect them all. He's got to put 6 electrons in somewhere
Can I
else.
put them around H?
He cannot put them around H because H is already happy with its duet that are contained in the single covalent bond. The chlorine, on the other hand, came to the table with 7 electrons. Only one of them is being used to bond with hydrogen. So we're going to put 6 electrons in 3 sets of lone pairs.
And as I count,
around
I'm going
chlorine.
to start with that 2 electrons that I drew from my dash in 3, 4, 5, 6, 7, 8. I'm done. I got my 8. And chlorine now has
8 total electrons. So he has to redraw it nice and neat. And he's got his final answer there. The next one, I'm going to start switching to a more visual representation of how to do this.
Yep. And it also
Milks is
incorporates
going to narrate you through it.
Yep. It also incorporates the first of the weird rules. So what Monaco is going to do is draw out each of the elements with just its lone electrons.
Just the valence, the Lewis structure of the atom.
Yep, that's what I meant to say. That's what I meant to say, the valence electrons. And I see that nitrogen is going to make 3 bonds. We know this from a POGO that we did in the past. And what's going to happen is one hydrogen is going to come in and make a bond, and another hydrogen is going to come in to make a bond. And now wherever I see that, though, this is where we need to redraw it to what he's doing. So this has got the extra step as far as redrawing, but that's how you get to this. But what I like about this is this shows you that each bond is those 2 electrons, one from H and one from N.
I look at it as like putting puzzle pieces together. Anywhere there's a single electron on one side of an atom, it wants a partner, it wants a pair. So I find a single electron on the other atom that it has to bond with, and I rearrange it and put it right there because electrons are always moving around. They're not always stuck at the top of an atom. They move all over the place. So I can do that. And once I pair them up, I circle the pairs and redraw the pairs as solid lines, and it works pretty much every time for me.
Yeah. And so what we want you to do is find one of these 2 methods that works for you and do that.
Yes. Over and over and over till you can't screw it up.
Right. And they both work every time.
Double bonds.
Because double bonds. All right. Can you do me a favor on this one?
Yeah.
Different colors for different atoms.
So different, so red
just-
O and a
it'll
blue
help.
O?
Just one O make it blue and the next O make it red so that we can see where those electrons go.
You got it.
It'll be
I
cool.
understand what you're talking about.
Yep, it'll be cool. So he's going to draw them out. Each oxygen has 6 valence electrons. Remember, first 2 at a time, then 1 at a time around the bus. Now, he drew them the way he drew them instinctually, because he wanted the lone ones in the middle, because what it's easy to do now is to circle those right out. Right? So that one's going to form a bond, and then this one's going to form a bond. And now how many bonds are between the two O's? I see 2 circles between the 2 O's. So we can redraw that in a certain way, and he's going to get there. There we go. There we go. Bring your lone electrons down. And we're not going to hem and haw too much about where each of these lone electrons go, as long as you have the right numbers on each. And notice each oxygen has its full octet. There's 4 in the dashes plus 4 lone or 4 dots. So there we go. 2, 4, 6, 8. 2, 4, 6, 8. Octets are full.
Done.
Okay. Now, can I do this one the other method so we can just see both methods?
Mr. Bilks is going to go the counting electrons method. Carbon comes with 4 valence electrons. Oxygen comes with 6. So 4 plus 6 was 6 is 16 electrons he has to play with in the first place. He's going to put carbon as a central atom, because that's what we're trained to do, put oxygen on either side and connect them with a single bond. So now he knows that he's used 4 of his total electrons, and he's going to put the other 12 around the oxygens. Why? Because oxygen came with 6 in the first place, so it's odds are it's holding on to them as well. Okay, so now he's going to count and see. Okay, he's used all the electrons. There's 16 represented there, but our octets are not satisfied.
Good here.
Both the
Good
oxygens are, but carbon
Not good here.
is not. So what we have to do is we're going to grab a pair of electrons from each oxygen and flip it in to make it a double bond. And so that when he redraws our molecule, there's double bonds between the carbons and the oxygens. And when he counts his octets again, he has full octets on all 3 atoms that are involved. Okay? And that's how you would get this deal. So I'm going to hit up C2H4 with my method and show you how it works.
So 2 carbons, each with 4 valence electrons, but carbon's special, remember. Carbon is just one at a time around the bus. Okay? Good. And then he's going to have 4 hydrogens. And he's going to start hopefully circling them up, because he can't just pull them in.
Nope.
Right? So let's make a bond between the carbons.
So I'm going to do this.
Okay, that's that one.
Right.
And then let's put some hydrogens on there.
Okay, so I'm going to put 2 hydrogens on each carbon.
Okay, let's do that.
So I'm going to put a hydrogen up here, a hydrogen up here, a hydrogen over here, a hydrogen over here.
And can you do that in your picture real quick? Just circle those up so we can see.
Yep, I put this there. I took another one and put it right here.
Uh-huh.
And this one I put over here.
Yep.
And this one I put over here.
And now
so
when we
I
do
have
that, we got that.
2 dots left over. What would 2 lone electrons want to do?
Pair up.
Pair up.
So make another bond there. Now you got your double bond. Bingo. Both of these methods work. They're both tried and true. You just got to pick which one are you going to do. Okay, let's go through triple bonds. We got a little bit. We're doing good. All right, so and
I'll do my visual and then you'll finish
picture method works great, especially for this one without his, they all work good. So notice his instinct though is to put the single electrons in the middle. It's easier to see them pair up. So if I take 1 from each boom, 1 from each boom, 1 from each boom, I got 3 bonds. Redraw ends with 3 bonds. And you're good. You don't forget to put in your lone pairs on the outside, and you're good.
I'm gonna count these ones up. I got 1, 4, and 5 is 10 electrons.
10 electrons to play with. He's going to put carbon in the center because that's what you do. Nitrogen on one side, hydrogen on the other.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
And then he's going to count his octets. Hydrogen's good with a duet. Nitrogen's good with an octet, but carbon is left out in the cold. It's only got 4 electrons around it. So he's actually going to take 2 sets of lone pairs from nitrogen and flip them in to make a triple covalent bond. And there it is. The last one, he's got 8 total plus 2 total. He's got 10 electrons total to spare. And so he's going to connect the carbons in a pattern that would be making a backbone. Okay? And he's going to put 1 hydrogen on either side. Now he realized he's only uses 6 out of his 10 total electrons.
8,
9, 10, squeezes them in, and he realized, maybe I should flip those in
Yeah, because this has only got
2, 4, 6.
6.
And that one's only got 2, 4, 6.
So if I go like this and pull this one in,
Yep.
and then go